So now we are in the first part of problem 1.3 and we want to determine v of t. And what we can see here is we want to determine v of t for two cases. One where we consider a time point after k, and one where we consider the time point t before k. And the difference in these two is that if we stand at a time after k and look into the future, then there are only benefit payments. Whereas if we stand at a time before k and look into the future, then we need to take account for both benefit and contribution payments. So let us try to look at the first case, t greater than equal to k. So the good old sense, we will draw an I here, and this is the time t I will be looking at. And then we know that after time t, we will have t plus 1 and time t plus 2. And there will be 1 unit of benefit at each of these times. There will also be 1 unit of benefit at time t. But when we talk about present values, v of t, we only talk about the time t value of future liabilities, which means that this one will not be counted in. So v of t here is equal to, well, let us take a look at the future benefits. The one at time t plus 1 will be discounted 1 period. The one at time t plus 2 will be discounted 2 periods, and 3 periods, and so on, up until we get to this number here, k plus n. So how many periods is that discounted? Well, we can write this as t plus k plus n minus t, right? So this thing here will be discounted k plus n periods, which means we have 1 unit that's discounted 1 period. So that has the present value v to the first. And then we have the next unit discounted 2 periods, which has the present value v to the second, and so on and so on. Then we have v to the k plus n minus t. And we can write that a bit more pretty with a summation. So we let s run from 1 all the way up to k plus n minus t of v to the s. And do you all recall what v is? V is the discount factor, and that's 1 plus I to the minus first. Yeah? Okay, so just before we move on, there is a little thing that we could probably note here, which is that actually v of t is just the time t value of a annuity in arrear that lasts for k plus n minus t periods. Also, if you look at the section for annuity in arrear, you will see that this coincides exactly with what is the notation a weird thing k plus n minus t. So we can also just use this notation instead. Okay, so now to the case where t is smaller than k. So what happens if we stand at a time point before k? That's our question. So now we will stand, for example, here. Now, what we note here is that there are both future benefits and future contributions. And the way we take this into account is by writing the present value of future benefits minus future contributions as the present value of future benefits in one term minus the present value of future contributions in another term. And what we'll do is we'll calculate them separately. So let us try to look at the present value of future contributions first. So we stand here at time t, and then at time t plus 1, there will be paid pi. Time t plus 2, pi will be paid, all the way up until time k, which is the same as time t plus k minus t. So pi will be paid once, and then twice, and then up to k minus t times. And the first payment will be discounted 1 period, the second payment will be discounted 2 periods, and the last payment will be discounted k minus t periods. So the first payment will be discounted 1 period, the second payment of pi will be discounted 2 periods, etc., till the last payment of pi, which is discounted k minus t periods. And that, my dear friends, we can write up as a sum, right? So we have pi multiplied v to the s, where we let s range from 1 up till k minus t. And what we know is we can take pi outside of the sum. So this is equal to pi multiplied by s equals 1 up to k minus t of v to the s. Now, I want to take a look at the present value of future benefits. And what we notice here, we don't really need to do the same counting thing all over because we actually know the time k value of future benefits. So if we know the time k value of future benefits, then the time t value is just the time k value discounted k minus t periods, because the number of jumps back to here is k minus t periods. So what we want is to discount this k minus t times. And what was it again, this present value of future benefits at time k? Well, we calculated that in the first case, where we have v of t is equal to this, right? So if I put the k here inside instead of the t, then I just get k plus n minus k, which is just n, in the upper bound of the sum. So that's an n, s equal to 1. Then I have v to the s inside here. Is this right? Yes, this is right. And what I can see here is I can also just move the k minus t inside the sum here if I want, but that's a matter of taste. So to sum up the second case, I have v of t is equal to v of b minus is equal to v of t minus vc of t, so it's equal to the present value of future benefits minus the present value of future contributions, which is then equal to, well, the present value of future benefits is what I got here, so v to the k minus t multiplied by sum from 1 to n of v to the s, and then minus this thing over here, which is pi multiplied by the sum from 1 to k minus t of v to the s. And as you recall, in the first case, I used some actuarial notation, and I'll also use it here because I don't want to write these sums again and again. If you look in the definition of a deferred annuity in arrear, then you will notice that this thing, well, it is exactly the same as what this symbol stands for. Because in fact, the present value of future contributions, the present value of future benefits when we stand here is just the present value of an annuity in arrear that has been deferred k minus t periods. And then the payment occurs for n periods. So that's exactly what I have here. And then minus pi multiplied by the present value of an annuity in arrear where payment lasts for k minus t periods. And that's also exactly what I can see from the payment stream, that if I stand here at time t and look at the future contributions, then this payment stream is just an annuity in arrear with payment that lasts in k minus t time periods. So to sum it all up, in conclusion, what do we have? We have that v of t is equal to, and then we have the two cases. When t is smaller than k, it is equal to k minus t an minus pi a k minus t, and k minus t, and when t is greater than equal to k, we may see up here that it is equal to a k plus n minus t. And just to take part 2 of this exercise as well, in particular show that v of 0 is equal to this thing here. Well, is it? So let me just copy this and we can put it down below. Well, what we do notice is 0 is a t that is smaller than k. And if I plug 0 in where t is, then I have exactly what I want. So I can just say, hence, v of 0 is given by what I wanted to find in part 2. So that is part 1 and part 2 of the exercise. And then the next part of the exercise, we will calculate pi according to the fairness criterion.